When we talk about better humans, I just want to put in my brief ethical comment, which is it doesn't mean that there is a best human. It doesn't even mean that there is a better human except for a particular task, just like a bicycle is better than a supertanker for certain tasks in transportation. And so, and I'm particularly concerned about any tendency to reduce our diversity, especially our neural diversity. So I just get that out of the way, although we can come back to it. And the other thing is, when we some people start talking about fantasies, and even worrying about the enhanced human being, it's things like, oh, well, what about blonde hair and blue eyes and being able to run really fast? And I sort of feel like that doesn't sound like a public health threat, number one. And number two is we can already do that. We put on contacts and dye our hair and get in a car and we go really fast, or a jet, better yet, or maybe a rocket. So put all that aside for a second. What can we do? What can we do in the near future that we don't already do? And I would say that boils down really to psychiatric, cognitive, and aging. And we're mostly talking about aging. And also, we're not limited to what is present in nature. In fact, I'm somewhat skeptical that we can do what we really want to do by adjusting our diet and our exercise and our state of mind. I think that there's kind of a cap to what can be done there, and a lot of us are already doing it, and we're going to, at most, live as long as Jean Clement did, which was 122 years, if we're lucky. And a lot of those last years won't be that pleasant compared to when we were 25. So I think of it as you can look in nature and say, oh, there's a lot of rocks out there, I can study rocks and that'll tell me how to build the Empire State Building. Or you can become an engineer and you can say, this is a tough problem, but it's definitely doable with current technology to do a deep dive. And what we're doing in our group is using gene therapy. In principle, we could be using small molecule therapy as well. But gene therapy is relatively easy to do, rapid prototyping. And we're not looking at longevity, because if we go to the FDA saying, I can extend human life by 40 years, sounds great. They say, come back in 40 years when you've got your clinical trial done. But if we say we can reverse aging, that first of all, it's already been done 8 different ways in mice, and it is easier to do in the lab, it's easier to get FDA approval, and so it has many attractions. And we do it with gene therapy because it's very easy to go from literally hundreds of genes that have been shown to be involved in longevity or aging reversal in various model organisms and turn them into gene therapies. We can do that in a matter of weeks and then do trials on pre-aged mice that are 2 years old, which is almost dead, and then pre-aged dogs which are 12 years old. We know that genetics has a huge component because we and others have studied things like bowhead whales that live 100 times as long as rodents do. And so what we do is we take the 300 genes on our short list from one of my postdocs' databases, Pedro de Megalis runs GeneAge, and take those 300 genes and ask, well, which subset of them are non-cell autonomous, meaning that they act on more than one cell, because our delivery methods aren't good yet. So in parallel, while we're developing better delivery methods, we want to just do it, the ones that impact multiple cells. And then that subset gets tested on pre-aged mice, and then those that look pretty good get done in various combinations. We've taken, in particular, 3 gene therapies all the way, where we've done every possible single, double, and triple combination, and have found various synergies and interferences, and then picked a 2-gene combination that seems to act on 4 major diseases of aging related to heart failure, kidney failure, obesity, and diabetes. And that's been submitted for publication, and my co-authors don't want me to say much more than that. But I'm very excited about not just that study, but all the ones that are just behind it in the pipeline. We have 50 more genes that we have to study in various combinations and various dosages. So I think that when we, these will then go from mouse experiments into dogs, pre-aged dogs, and that becomes a product, kind of a pause for us, because people care very deeply about their dogs. They'll spend $50,000, $100,000 at end of life. That doesn't really help them or their dogs much. They'll clone their dogs, which isn't fundamentally different from getting another puppy from that breed. What they really want is to have a happy, healthy version of their current dog with all the memories and so forth. Dogs are great because they live in our environment, they eat our food, we can tell when they're having a bad day. Maybe you can tell when your mouse is having a bad day as well, but I think it's a little bit easier with dogs. And then we will quickly move from that into human clinical trials right after that. So I'm looking forward to the conversation. Thank you very much.